Welcome to Developer Server's YouTube channel. On today's video, we're going to be creating a natural language terminal in Python with MistralAI Codestral Mamba that was just recently released. And what is Codestral Mamba? Codestral Mamba is the latest model from MistralAI. It's a code model. As you can see, it was just released on July 16. It is a fully open source model. In terms of performance, you can see even despite it being a smaller model, a 7B model, it performs most of the other code models like Codestral Mamba, for instance. And it can be used either with Mistral Inferis SDK or like we're going to be using it with the cloud version available on the platform. And like I mentioned, it's full open source, open under the Apache 2 license. So that means you can use it for commercial and non-commercial licenses. Before we build our terminal, you might ask, why do we need a natural language terminal? Why can't we just learn the terminal commands itself? But the command line interfaces can be scary for people who are not familiar with the syntax. And even for experienced users, it can make them more productive, because instead of remembering the commands, they can just type in a natural language. For beginning, it's obviously a very helpful learning tool, and additionally, it can also be trained or customized to fit specific needs or uses. So in a specific company, if they have scripts or commands that they normally use, that can be added as a learning to the language model, and that makes it easier for the execution to remember those commands. So those are some of the advantages. And the Codestral Mamba, like I mentioned before, it is a very recent model. It's also one of the very high performance models, and it's open source. So as you can see, we are in our PyCharm project. We have an environmental file that defines the Mistral API key. And so obviously we are going to use the MistralAI. So besides the Codestral, like I mentioned, you also need to sign up to MistralAI, and you can just go to MistralAI and log in and create an API key. So we're going to be needing the Mistral API key, which we'll define in the environmental variable. In terms of requirements, very few. We need to install Rich, because we're using the library Rich for an interactive terminal. MistralAI, of course, so we can call the cloud version, and Python decouple, so we can use the environmental variable. We have our Codestral wrapper, where we have the logic to call the Codestral model, along with the system prompt necessary. And we have our main.py that takes care of the main logic in recognizing the commands typed by the user and calling the Codestral. There is two different versions of this project. We have one first version that is simple without any history or without detecting the operating system. And we have one that is underscore history, both for the Codestral, where it will have the history, and both for the main one, where it will detect the OS information, so the operating system information, so it can contextualize it better. We will mainly focus on the version without the history and without detecting the platform information, and then I'll show you the differences from one code to the other, and obviously show the execution of both of them. So let's now take a closer look at how the code is built. So we start up with our Codestral wrapper. So obviously we need to import JSON, because we're going to be loading the commands into JSON. We have our config, so we can load the environmental variable, Mistral client, obviously, to call the Codestral, and also the set message, because we're going to be using Codestral as a chat interface. First thing we do is we load our API key from the environmental file. We instantiate our Mistral client with the API key. We define which model we're going to use. In this case, we're going to say Codestral Mamba, the latest version. You can specify a specific version if that makes more sense for your use case. Then we define one single function, which is the get natural language command, which receives the prompt. This is the prompt is the text that the user wrote. We define our system message and also our user message. We start with the system message, and we explain and give the context to the AI that it's an eligible AI system that can translate the natural language commands into shell commands. It's available in various programming languages. And the important thing is we specify how the response should be. So the response we specify it should be JSON in this specific format, so it will return the command and also an additional description to show to the user. We'll make the command safe and useful to execute. And again, when we pass in our, so that was the system message, the user message, we just say that we want to translate the command that is passed, and that is the prompt from the input parameter. and we reaffirm that it should be the JSON object with that the output should be the JSON object with the command in the description. We then call the chat API, which obviously passing the model, the Codestral model in the messages. We load the response into a JSON and return that JSON command, and that JSON will contain the command to execute and the description. And that is all for the Codestral wrapper. As you can see, very simple implementation. So next we have our main file. We start by importing subprocess because we want to execute the commands. From which we import both the console and the prompt and confirm, so we can interact with the console and with the user. And of course, we import our natural language command from the Codestral wrapper. We start by initializing the rich console, so you define a console. Then we define a function that executes a particular command. And this command is either the command in natural language that has been translated to a shell command, or an actual shell command that the user is passing. So we simply do our subprocess and we run that particular command. We run it in the shell, we check it, we capture the output, and it's also text. And we return the standard output as the result of the execution of the command. If there's an error, we will return the standard error. Then we define our main function. We start by printing a welcome message. So we do a console, and console is the rich console that we initialized before. So we start by printing some messages. We're going to print in bold the title of the tool in its terminal tool. Then we're going to be writing the prompt. We type the command or type exit if the user wants to quit. Then we start the main loop, and it's going to be a while true while the user does not type true. So we start by getting the user input. We have a specific prompt that says you, so that user can type its prompt. We use the prompt from the rich package. So then we check if this user input is exit. In this case we break. That means that we go out of the while loop and we finish the execution. We check if it's an actual shell command that has been passed, and we do that if the command starts with, if the prompt starts with exclamation mark, then that means that the user is actually passing a shell command, and then we just retrieve that user input, ignoring the first character, which is going to be the exclamation mark, ignoring the first character, that defines the command, and that then gets executed later on. If the user has not prefixed it with the exclamation mark, that means it's a natural language command, and we need to interpret it. So we call our function that we saw before, the get natural language command. We pass the input. This returns to us a JSON, and the command to actually execute is going to be in the JSON command dictionary key. Then we're going to show that information to the user. So we're going to show the proposed command again from the JSON command key, and we also show the description that comes from the JSON command description key. We're going to be asking for confirmation of the execution. So we're going to be using the confirm from the rich library. I'm going to be asking the user if they really want to execute the command, and we're going to be showing it in red. If the user has not confirmed the execution, so if they don't want to execute, then we're going to be saying that the command has been cancelled, and continue, so that we go back to the user input to get the next command from the user. If the user has agreed and we have a command, then we're just going to print that we'll be executing that command, and that command can be a direct command or the command from the natural language translation. We're going to be executing that command with the execute command function that we saw before, that we defined before. And we're printing out to the console, the rich console. We're going to be printing out the output, meaning the output of the execution of that command. And of course, we define our main entry point for this script, which simply calls the main function, which has the while true, and that is waiting for the user input. And that is all that is needed to implement our natural language terminal. Now let's see some examples of the terminal running. Since I am in PyCharm, I could actually just run the file that I have selected now, but to fully have the effect of the rich package and see the colors and the interactivity in the terminal, it is best to run directly from the terminal, and we're going to run our python min.py. So we have our nice terminal tool in green. We have the text, and we have the prompt defined by you, like we saw that before. So I'm going to say create a directory called test in Windows. In this case, I will need to specify what is the operating system so that the command matches my operating system, which is Windows. Now we see later on, once I show the automatic detection of the operating system, that this is no longer necessary. But for now, in this version, we need to pass. So let's see the translation. As you can see, we run our Codestral through the API. We have a proposed command, make dir test, and with a description that creates a new directory name test in the current working directory. It's asking me if I want to execute this command or not. This is all built-in function with a confirm ask from the RISC package, and so I'm going to say yes. So it has executed the make dir test. I can now also say to be create a command to list the contents of the current directory in Windows. So we have our pop command here, and we're going to be executing that command. As you can see, we have all the directories here, and we have the test directory that was created by the previous command. And that is it. As you saw, very simple code that is needed. Obviously, the main workload is done by the Codestral Mamba model, but of course we can also improve this implementation, and I'm going to show now how we can add history to the chat so it remembers our previous commands and it's easier to interact with, but also how it can detect automatically the operating system so that we don't need to always be specifying that it's on Windows. Let's see what is the code changes. So we start our code changes in the Codestral wrapper. I'm showing now the history version. So the main differences is that we have now a list that will store the list of commands or the history of commands. So it's just a simple Python list with that we call history. The get natural language command has also been changed, and now it receives the operating system name, release and version. So we are changing a little bit the way that we prepare the system message so we can add the comments. So now we're instantiating first a variable system message, and you pass the initial part, which is the description of the AI and also the JSON format. We're passing in a second or appending a system message that passes in the operating system information, and then we're iterating for each of the possible commands in the history, and we're appending that to the system message saying that these are the previous commands. We pass both the prompt that the user typed and also the corresponding natural language model, the translation of the natural language model for actual command, and also the description, so that gives the AI the complete history of what has happened before. We pass in our system message, which now comes obviously from the system message when we are defining the message for the chat, and the same thing we're passing still as the user message that will be translating the command to the prompt. We're passing in an additional contextualization to only return the commands that are valid for the user's operating system to reinforce the definition that we have here in the system message that the user is running that operating system. Again, we're calling the chat with MistralAI, passing in the model, passing in the messages. We're extracting we're loading our JSON from the output to the JSON command variable. And then, of course, we need to store the history so we can use it in the additional commands. So we're just going to do an append to the history, the prompt that was the prompt that the user typed, the generated command, and the generated description. And that's going to be part of the history. That then in the subsequent message is going to be added to the system message with new code that we saw before. And of course, we still return the JSON command afterwards. In terms of the changes on the main file, we're now seeing the main history file. So obviously the big change is that we have now an additional function which gets the operating system information, the getOSInfo, which gets host name, release, and version from the platform. And of course, that means we also importing platform. It's a Python built-in package that returns the system that we're using, the release, and the version. And we're just outputting all three of them from this function. And that means that we now start the main function by getting these variables from the function that we just saw. We are printing that additionally in the terminal also to contextualize the user and to have that information very, very clear. The rest of the logic is the same. We do our while true. We get our user input. And we check if the user has used it or not. If it is an actual shell command executed. If it is not a language, if it's not, and if it's a natural language command, then we're calling still the get natural language command, user input, and now we're passing in the platform information or the operating system information additionally. And then we have the same logic. We print in the command that was there, we ask for the confirmation, we execute the command, and we print the result to the console. So let's see now the version with history and with automatic operating system detection in action. So as before, I'm going to run directly from the terminal so we can have the beautiful colors. So I'm going to run the main history.py in this case. So as you can see, this is our first difference. It now shows, besides the title, it shows the operating system information, which is in my case Windows 11, and this is the version. So if I would say now the same command that we typed before, create a directory called Mistral. Let's type a different name. As you can see, since now it has the contextualization, I did not need to specify it was on Windows, and it said the make tier Mistral. And I can confirm the execution, and I can now say create a command to list the current directory. As you can see, even with some typos here, it will recognize, and it shows D because it knows that they are in the Windows operating system. I'm going to execute that command, and again you see that our directory has been created and has executed successfully. Let me show you the chat history actually that I did not show. So we can say delete the previous created directory. So as you see, it remembers that I created the directory called Mistral. So it says to remove the directory Mistral. It's even as the description is going to be deleting that. And if I say yes, it's going to be deleting, and I can execute the command directly. And as you can see, Mistral has disappeared as a directory. So that's also the chat functionality. Very easy to add the history to the chat, very easy to add the operating system detection, and very little code that needs to be implemented to have the natural language terminal working. So like this video if you like this content. Follow me for more content about AI, Python, and Django. And until next time, happy coding!